Hey, and in this video, I'm going to be doing a TED Riddle talk, but in Python. So in this TED Riddle talk of wizards, we have a tournament, right? And in this tournament, we have 3 wizards. And each wizard has a % chance to essentially kick out either one of the other 2 players. And starting in position 1, which is us, blue player, so watch the video if you haven't already, we can shoot either one of the other 2 players. And then the next player can then shoot either one of the other 2 players, assuming that there is 2 left and not 1 left. If you get to the end of the game and all 3 players are still alive, then everyone is kicked off. Everyone is converted into cats and lose. If, however, there's 2 people left standing, then they'll keep shooting each other until one person wins. And in the game, you can actually choose to miss and not shoot someone if you wanted to. So we won't actually be solving the riddle in Python, and today we're just going to be actually just doing the tournament itself and just creating it. So in order to do that, we need to essentially do a couple of things. So in Python, we need to determine what we have, right? So we know that we have a game, and we know that we have 3 players. So in order to do this, I'm using IntelliJ. You could also use Python. I mean, not Python. We are using Python. You could also use PyCharm if you wanted to, which would do the exact same thing. So all I have done is I've just done a file, new project, and then in that I just have a folder, say scripts, right? And then all I've done is I've just done new, a directory, to create a new directory, which is this here. And then you can just go to new Python package. When you do this the first time, it will immediately just create an initializer and it will just like add like a dot name for some reason. I don't know why that is. But then if you do it the second time, then you can do it again, new Python package, and you can create your player and your game. And when you do this, it will immediately create the initializers for both of these. So I'm just going to go ahead and create my players. So I know that my players, right? Uh, Actually, I first have to create my players. So I'm going to say class player, and my class player will need to have the initializer. So what the initializer does, press enter. What the initializer does is that it sets up the variables that this class has. For example, the class, for example, will have a name. So I'm creating 3 players, right? So each player will have a name or a color. So this is, say, player blue, which is us, and they have an attack chance. So player blue will have, let's say, a 60% chance to hit player 3 or player 2. And a red player will have a different attack chance. They might have maybe 60% to be able to shoot 1 or 3. So we have a name, and we also have an attack chance. And in doing a class, you just have to do self.underscore, and then you're essentially just setting the variables. So this is the same for every single class. So all I'm doing here, right, is I'm giving the class player a variable called name, and I'm setting its value to whatever I pass in as a name. So if I pass in, let's say, blue here, then this will be blue, and this is assigning the string of blue to the variable. And you do the exact same thing with the attack chance. And then every single class, like ever, will always have getters. So all that a getter is that it just gets the variables which will be private. And when you do open bracket, it will immediately write self for you. So when you write that, when you write just a open bracket, it will immediately do all this for you. So getName is just going to return the class's variable name. Remember, again, you do this just because rather than interacting with the variable itself directly, you should use methods to do it for you. That way you're not actually touching the actual variable itself. You should touch a method which gets it for you by returning it. And so we're just going to do the exact same thing, but we're going to be using the attack chance this time. Attack with chance. And we're just going to return self.underscore attack chance. Great. So now whenever we create a new player, right? Whenever we create a new player, they must have a name and an attack chance to be made. So I'm just going to now create my players. So this is red currently because I haven't made a game class. That's fine. So I'm just going to create my 3 players. So I have blue player. They're gonna be a player type, and they have a name. So I want them to be blue, and they're going to have an attack chance, which will be, let's just say, 60% chance to attack. And then we're going to do the exact same thing for red player and yellow player. Remember that the blue player is us, so they will have some different characteristics. Later when we get into the game, we'll work that out. So red player, they're red, yellow player, they're yellow. And red has a 70% chance to attack, and yellow has a 90% chance to attack. And then once we've done that, then we just need to put all of these into a dictionary. So we can just go ahead and just do that. So we're just going to say my dictionary is equal to a new dictionary. And we're just going to pass in like the index of this and, needs to be colon, sorry, the index and the variable. So blue player has an index of 1, index of 0. Index of 1 is for the red player, and player index of 2 is to player yellow player, player 3. And then we can just go ahead and do a we're going to create a match, a tournament, right? So the match is going to be a game class variable. So remember, I haven't created it yet, so class game. We'll do that in a second. So it is going to be a game, and it's just going to pass in this as a parameter. And then once we've done that, we're just going to use the class's method, which we haven't made yet, and we're just going to call it match.nextRound, and this will be the actual thing to constantly cycle through. So this bit here will make sense. I'm going to do it right now, and then I'll do this later. So we first need to create a game. So every class has an init. So def underscore underscore init. Done. And so a game, right, is going to have the players. So in this case, in the players that I'm passing in as a parameter, I am passing in my dictionary of players. So blue player, red player, yellow player is being passed into the game. This is game 1, so I just need to change this. Game 1. And then this should immediately fix up. Class game 1. Sorry, from game, import game 1. Yes. Game 1. Okay, there you go. Now that's working. So all that this does, right, we're just doing from game. So this is from game. Import game 1. So in the init, this is game 1. And this is currently red because there's supposed to be stuff in here, right? So we know what to do already, right? So what to do is just do self.underscore players is equal to actually we'll just call this we'll call this dict just so we know that it's a dictionary. And this will be equal to the players. So yeah, you can see all the red has gone away. That's because this class is now working essentially, even though it does nothing currently. And we're also just going to create, just out of ease later, we're also just going to do the players themselves, right, is equal to players dot values, I believe it is, and that will get the second element. So remember, oh crap, what did I do? So there are 2 elements in every like part of the dictionary. So there is 0 and then there's blue player. So if I get dot values, it should get the second element, which will be the blue player. So the second element is blue player, then red player, then yellow player, ignoring the key. So if I did dot keys, it would get this and this and this. But I'm doing dot value, so it gets me this and this and this. So look up Python dictionaries if you don't know how to use them. But you can use dot keys bracket bracket or dot values bracket bracket. Either one will work. And we're also going to create a new variable which we're not passing in. And this will just be the round number. So every single point in the tournament, right? So we'll have round 1, round 2, and round 3. And when we get to, say, round 4, then we want to restart back to us again, to blue player, right? So we already know that we need to do that. And then I'm just going to do some getters again. The getters are super easy. You probably just skip this part if you want. Self immediately, just do return self.PlayerDict. I'm gonna do another one. Get players. Return self.PlayerDict. Done. And also get round number, and probably do a reset round number in case I need to. Def get round number. Return self.round number. Remember, this is just for access ways because you don't want to access the exact variable itself. And I'll do another one. I don't know if I'll use this at all, but I'm just going to create it anyway. Reset round number, and this is going to just get the current round number. I'm just going to reset it back to 0 again. So we're going to be incrementing this throughout the game, right? So if this becomes to be 3, then we need to reset it to 0 to come back again. And then we need to do another thing, which is a bit more complicated, is that we need to get the next player turn. Next player turn. I guess I'll just come back to this in a little bit. So first we need to do the actual major things. I'm just gonna give some space for a sec. So the actual major thing that we're gonna be doing is we're gonna be doing next round. So not match. So the main method will be next round, and all that is just going to keep cycling through. So this is like the main thing that actually runs everything. So if I create a method, right, and call it next round, so we're gonna start at turn 0 for a moment. So we're gonna say while the game is still in play, then we need to start continuing. So round 4, for example, will adhere to restarting back to player 1. So round 4, so after all turns, or one person left alive. So let me just write this and make it some more sense. So while self dot, so we need to check if the game is still in play. So I'm going to make another method, and we need to check if the game is still going or not. So we're going to say, just call this game over, and we're going to say while it's not true. So so if the game over, for example, if game over is false, then that means that it isn't game over and we're still in play. So we're going to be continuing. But if it is game over, if it is equal to true, then we need to stop and find the winner and print out whoever the winner is. So in order to do this, I'm just going to say pass for a second and create another method, and this will be game over. Game game over. So we're going to create a new method called game over, and we need to first do a check first if there is only one player, one alive player. So we're going to say, just create a new variable, count of dead players. And how we're going to be doing this, right, is with our players, right? We're going to say rather than just deleting someone if they're dead, because then everything will get moved into one point and it might get a bit confusing as to whose turn it is. What we're instead going to do is we're just going to replace the blue player with just the value of 1. So so the positions will be kept. So if red player gets killed, then this will be 1, 1. This will be replaced with the number 1. So the positions will stay the same throughout the entirety of the game. So the count of dead players, we're going to say it's currently 0. And we're going to say for the key value pair in self.PlayerDict.items, right? So this is how you get the key value pair of a dictionary. We could do it like this, or we could also do like this. So this would be the exact same thing. You would do self.PlayerDict. So this would be the exact same thing as this. Exactly the same thing. So for the key value pair, right, if a val is equal to 1, then we're going to just increment our count of dead players plus equals 1. So we're checking, let me just give it some more space, we can see. So we're just checking if there is only one player left alive. So if we go through the entire list, right, and if this becomes, the count of dead players becomes 2, if there are 2 dead players, then we know that there is 1 left alive, and we therefore know that they've won. So that's what we're checking for, pretty much. So we're going to say, once we get to the end of the loop, and we've counted all the dead players, if the count of dead players is equal to 2, then we can pretty much just run, we can just do, you've won, pretty much. So I'll probably just add some stuff to this later. So if only one left alive, then you win, right? And you could just do like a print, you win or something, you win or whatever. But I'm gonna do some more stuff. So I'm just gonna say create a new method for later, and we're just gonna call it winner. And this is just going to return true then. This is just to say that there has been a winner, and we're going to return true. So I'm just going to finish off this method, and then I'll go to winner and show you how that's going to work. And then we're also going to do else. So if the game is still in, else check if at round 4. So if we're at the end of the game, if all the players have gone, then we need to essentially keep checking until there's only one left alive. So we won't check at the beginning, so we'll go 1, 2, 3, and then when we get to 4, right, then we need to keep checking because there should be only 2 people left alive. We need to wait until only 1 is left alive fully. So in order to do this, I'm going to say elif self._round number. Remember, you should actually be using get round number, but I'm just going to be using this just for simplicity. I'm going to say when that is not equal to 0, so I don't want to be checking it before the game's even started. I want to check once everyone has had one turn, or those left alive anyway. and self dot underscore round number divisible by 3 is equal to 0. So remember, we're starting round number at 0, right? We're starting round number at 0, so it'll be 0, 1, 2, and so it'll be round 3 that we start checking on round 4. And then we're going to say or the length actually, we're not going to do it. We're going to say or the self dot underscore round number is greater than 3. So after round 3, so at round 3 or after round 3, then we need to keep checking essentially like where we're at. So we're going to say if everyone is still alive at this point in time, so if we've gotten to round 3, if everyone's had a turn, if no one's fired, then we need to end the game and turn everyone into cats. So we're going to say if everyone is still alive at round 3 plus, we're going to say turn everyone to cats. So we're just going to say if this is all still together, so we can still use this. If the count of dead players is equal to 0, so if there is no positions which is equal to 1, so if blue player still exists, red player still exists, and yellow player still exists, and there's no 1 in either one of these positions, then we know that everyone's missed. So then we can just say print all were turned to cats. And then I'm just going to do return true to stop the game from continuing. And then I'm going to do, then we need to check if we've gotten to the end of the game, well, we've gotten to like round 3, right? We've gotten to the end of it, right? Then we need to then check if one player is dead. So if there are 2 people still alive, then we need to continue the game. So if one player is dead, then continue game. So we're just going to do elif count of dead players is equal to 1. So there's 2 people still left alive, and we're going to return false to indicate that the game should still continue. And then we're going to do else. So if none of these conditions were met, then we're just going to say we can assume that there was a winner, even though this should be checked up here. This should be definitely checked up here. Because if the count of dead players is 0 or 1, then it should be 2, so it should already be done, so I wouldn't even need this. I'm just going to leave it out. And then, if none of these conditions are met, then I'm just going to say just keep going with the game, pretty much. So let me just go back again. So we have next round, right? So while the self.game is not equal to true, then we need to, I'm going to say print game started at round, and then if you just do curly braces like this, then you can just do dot format, and this allows you to just insert something in place of those curly braces. So I'm going to say self dot underscore, actually no, rather than doing self dot underscore round number, I'm just going to show you how to use the method. So you just do self dot get round number, and then just like that, that's the exact same thing as this, exactly the same thing. So you just do self dot and not self dot underscore, because it's not like an inbuilt member variable, it's a method, so it's self dot, not self dot underscore. So we've done that. Then we're going to say get the next player in the dictionary and skip over any positions which have 1 in it. So while the game is still continuing, we want to print the next round number, and we want to get the next player at the next position. But we don't want to get the next player at the position if it's a 1. We only want to get it if there's actually a player there. So we're going to say player is equal to, we're going to create a method for this. I'm just going to say self dot, I haven't created this method yet. So, actually I have, next player turn. So that's there already. And then we're going to pass in the turn number, and this will just give us the index essentially. And so what I want to be doing in the next player turn is, I'm just trying to think. So next player turn, we're going to say that the player is equal to self dot underscore dictionary at position. So currently all that we're going to do to get the next player right, the next player will be equal to blue player, let's just say, right? But what if blue player was a 1? Well, that's what we need to check for. So if the player is equal to a 1, then we're going to say the new position is equal to position plus 1. And so we're just going to put in a try here, and we're going to say because when we're getting the name later, if we try to use .get name, it won't work. So that's why I'm just putting in a try. So we're going to say self dot underscore dict new position. So if we get a player and it's actually a 1, then we're just going to try to assign. So if it equals a 1, then we're going to move to the next position. And then we should be able to use the like its variables. So if it's a player, then we can use get name and attack with chance. So we're just going to make sure that that's definitely working. I'm going to say accept. So if we get an error, it's probably because we're at the end of the loop. So what we need to do then is do new position. We need to just reset it to 0 to go back to the start of the loop again. I'm just going to say player is equal again to the same thing. And then we're just going to return that player. Yeah, that looks right, I think. And then once we've done all of that stuff, right, then we can just say who is our current player. Let's just see who that is. So we're going to say the current player is do dot format. We're just going to say player, whoever that is, dot get name. So if we got to the end of the loop, then this would cause an error, which is why you have to do new position 0 to restart from the beginning of the loop to get the player again. Remember, if the player is equal to a 1, then we don't want that, because then we can't use player.getName because they won't have any variables or anything that we can use, which is why we have to check for that. And then we can just go ahead and just do that. So it might print out, say, blue, for example, because it'll be player.getName, and player.getName returns the name. So if this is blue player has get name, which will be blue, and attack chance is 60. So if we did get attack chance, it would return 60. Okay. Then we need to do 2 conditions. So if the player is us, then we get to choose who we want to attack. Otherwise, they don't. So we get to choose who to shoot. We'll say if player.getName is equal to blue, which is us. Then we're going to say choose target is equal to the string of the raw input. And we're just going to say who would you like to shoot. So this just gets input from the command line. I'm just going to say self dot. We're going to create a new method again. I'm going to say attack target. And so for this, we're just going to set in the target of who we want to shoot at. We want to add in the chance to hit. So player.get. Player.attack. What's it called? Attack with chance. Player.attack with chance. And we're just going to pass in our self as well. Because I want to say in this method, which we're going to make, for example, player blue attacked this player with this chance, let's just say. So we need to create the attack target function, attack target method, so I'm just going to create that. So I'll say def, we're going to say attack target, and this is going to take in a target, chance to hit, or whatever I want to call it, chance to hit, and we'll just say player 1. So we need to create a random number generator, so we have a chance to hit, right? So we're going to say something along the lines of, well, we currently have a 70% chance to hit. So we're going to say that chance to hit plus a random number dice roll. If we get like 100% chance to hit, then we're going to hit them, right? So I'll show you what I mean. So random number is equal to random.rand int. I'll need to import random too. Import random. Random.random, yeah, import that. 0 to 100. And then we're going to say the RNG, the random number generator, is equal to the chance to hit plus our random number. So let's say our chance to hit is say 70%, right? So if we were to get 70% chance to hit plus we get a random dice roll of 50, then that's over 100% chance to hit. So therefore, we've definitely hit them, and therefore we can do something. Now I'm just going to do a bit of a loop here. Sometimes I do loops this way. And we're just going to say if the RNG, the random number generator, is greater than or equal to 100, so if we've hit them, then we can start doing stuff. And we're also just going to say else as well. Else print, and this is where player 1 will come into it. We'll say player miss. We're going to say dot format. I'm just going to say player 1. So remember, we're passing in get name, I believe. Yeah, we'll say it passing in get name, so this will be blue, for example. So player blue missed, let's just say. And that's all that's going to do. And we're going to say if the RNG is greater than or equal to 100, we're going to say for player in self.getPlayers, we're going to say something along the lines of if the target, so if we're shooting at the red person, we're shooting at red, and player.getName player.getName is equal to red. So what I'm saying is we're going through all the players, right? So we're going through blue player, red player, yellow player, right? We're going through the entire list. And we need to check blue player.getName, blue. Is our target red? Well, yes, let's say our target is red, right? So we're going to say blue player. Is your get name red? No, it's blue. Red player, is your get name red? Yes, it is red. And we were targeting red. So then we can, our target was red, so we wanted to shoot red. And the player in that list that we're currently cycling through was red. So then we can just say, we're going to say print player I'm just going to say dot format something along the lines of player 1. So we're going to say player blue hit we'll just say red. Doesn't even need to be anything. And then we can also say something. We can also we need to increment the counter. So we need to just do that. Actually, so we'll do that at the end. But we also need to replace that location. So if we've hit them, we need to replace that location with a 1. So we're just going to say the place at this position is equal to 1. Now I need to do this similar thing. We'll say for yellow, exactly the same thing. Oh, redo. Say you've hit yellow. Player blue hit yellow, and they do the same thing. And we can also choose to miss as well, which is also an option. So we're just going to say lf target is equal to null. So if we're going to miss on purpose, then we're going to pretend that we missed, right? So we're just going to say we're going to do the exact same thing as this. So if we missed on purpose, we'll just say that you missed. Then once we get to the end of that, we just want to increment the counter. Plus equals 1. Great. So we've done that, then we can go back to next round. Oh, God, long day. This is actually pretty long. Then what we need to do is we need to then do, so if the player's us and we get to choose who to shoot, if it's another player, so if it's red or yellow, then else just perform a random roll chance to hit. So if it's not us, if it's one of the other players, then they can just go ahead and do their thing. So we'll just do pretty much the same thing as this, pretty much. But we need to select who we're shooting at. So obviously we can't shoot at ourselves. So we're going to say random number is equal to randint 0 to the length of the amount of players. Self.getPlayers. So we're going to say if there's 3 players, then it will go from 0 to 2, I think. Yeah, so it'll only get the players which can actually be fired at, other than us. So we need to say, that. I'm going to say while the player is equal to self_dictionary random number. So if we're shooting at ourselves, we don't want to do that. So we need to keep re-rolling to target a new person. So I'm going to say that, or if we're shooting at a place where there's no player to shoot at. So the dictionary at the position of the random number is equal to 1. So if we're shooting at ourselves, so if the current player is equal to the position that we just rolled at, the position inside the dictionary, then we're shooting at ourselves. If the position in the dictionary is equal to 1, then the person is already dead and we can't shoot them. So then we just need to re-roll pretty much. We need to roll a new number to find a new position to shoot at. And so then we're just going to print, assuming that we now are shooting at a correct position, we then need to say player, player red, for example, attempted to shoot at player something. So red attempted to shoot at player yellow, for example. We do dot format. We need to do dot format player, the current player that is firing at the player that is being shot at, which is the self. Oh, all right. So the current player is shooting at self._players. I'm going to say that position dot get name. So player red. So the player, the get name, attempted to shoot at player. The player at that location get their name. That's what that's doing. So we're getting almost to the very, very end of this long method. And we're going to create a new function. We're just going to call it roll chance. So it's going to be pretty much the exact same thing as this, but we won't be allowed to choose who we want to shoot at. That's why I'm doing a new one. So roll chance. There we go. And we're going to say this takes in the player dot attack with chance. Attack with chance, and the random number, and also the player.getName. Player.getName. So I'll do that in a second. It's pretty much the exact same thing as we did before. I'm just going to say show who is still alive, and create another function again. We're just going to say who's alive to still keep shooting. So we're going to say self.remaining players. And this will just get whoever's left. Then we just want to increment return, and we're going to do the same thing for the round number. I don't know why I'm making 2 of these since they're like the exact same thing, but I don't know, it's just my crazy logic. And then we're going to say if at turn 3, then reset back to player 1's turn. So we're going to say if turn is not equal to 0, so we don't want to do it on the first turn, and turn is divisible by the length of self.players is equal to 0. So if we get to turn 3, then we need to reset. So we say turn is equal to 0. So it goes back to player 1. So turn is now 0, right? So now player is equal to set next player. So now turn is 0, so it'll get the first person in the dictionary. Great, so I think that method is all done now. So now I just need to do roll chance. I'll do that first. I'll do roll chance. So I'm just going to do def. Make sure this is spelled exactly the same way. I'm going to get problems. Roll chance is equal to this pretty much. Chance to hit. Oh yeah, I need to pass in the chance to hit. and the position that we're shooting at, and the player ourselves. Great, so this is pretty simple. All we need to do is get some more space. So if we've definitely hit, then we'll just say print player blah blah hit. So player red hit someone. Well, don't care who it is right now. Player that dot format. We're just gonna say player. So this is just the player dot get name, which we're passing in as player. And then we're just gonna say self dot underscore. We need to set, if we've hit them, then we need to set that position to be 1. So they're no longer in the game. Then we're going to say else print player blue, for example, missed. Or player red missed or something. Yeah, and that's done. And now we can do the remaining players functions. Let's just go ahead and do that. Not counter, this needs to be a position. Oh, crap, pressing things. We need to create another method, and I'm going to say def remaining players. Make sure this is spelled exactly the same. Ugh, I'm back. Okay. I'm just going to say print. Do this on a new line. I'm going to say players alive include. Da da da. I'm going to say create a counter while we're doing this. I'm going to say while the counter. We're just going to go through the whole loop and just get everyone's name and print it out pretty much. So while the counter is less than or equal to the length of self dot get players -1. Why are we doing this? Because the length is more than the actual number of positions. So there's 3 players, then there's only positions 0, 1, and 2, not 3. So I'm going to say if self dot underscore dictionary counter is not equal to 1, then we can go ahead and take them out. Well, we're not going to include them, I mean. Dot format. We're just getting the remaining players. Counter plus equals 1. I'm just doing else. If the position was a 1, then we still need to do a counter anyway. And then we still need to increment the counter even if there's no actual player there. So that we can keep cycling through, otherwise it won't cycle through. Great. So now, I think, just checking that we have everything we need. We also just need the winner. I think I did winner somewhere. Yeah, self.winner, so we need to do that. So you can't actually delete an item while you're iterating through. That's why we need to replace all the characters, all the players with 1s. Because if you tried to delete them, if you try to delete the players while it's iterating, then you can't do that. So instead, we need to do it this method. I found this on W3 Schools. So W3 shows how to delete, because you can't delete while you're iterating through. So I'm just going to say create a new list of items to delete. You have to delete them all at once you have all those that you want to delete. So for a key val pair in self.underscore_dict.items, so this is how you get the key value pairs of a dictionary. If val is equal to 1, and if you're wondering why I'm doing this and not just getting out the variable which we made earlier, dot vals. It's just because I'm just showing you how to do it. But remember to actually use the getters that you've actually made. I'm not doing it because I'm just showing you how to do it. Otherwise, through other methods. Delete.append key. So all those players which are actually a 1 now and not an actual player, we need to just append that to the list that we want to delete. Then once we have them all, we can all delete them all at once. Because you can't delete as you go, as I said. I'm going to say for the index in delete, I'm just going to say delete self._dict at that position. Then we're just going to say do another for key val pair. Do another one. And we're just going to say print the winner was dot format val dot get name, whoever that is. So I think that is everything. So I'm just going to make sure that I have everything. I have a winner to check whoever is the winner. I have a game over to check if the game is still in play. I have remaining players to show whoever's left to fire at. I have attack target to allow the player to choose whoever they want to shoot at. I have a roll chance for a random number generator of the other players. I forgot an else here actually. For else, I'm just going to say all this is inside the else. So if the player isn't blue, so if it's player red or yellow, then they'll be able to fire through this method using roll chance rather than attack target. I think that is everything that I then need. Just looking through, and then I think I might just try to run this and just see if it works. Fingers crossed. I'm just going to move this main over here. Let's try right-clicking main, doing run main. Run this. So line 109. So I might have just forgotten something. Game over. Rather than doing this, I'm just going to say, rather than PlayerDict, I'm just going to say self dot underscore dict dot items. I'm going to say try running that now. Okay, who would you like to shoot? Some player blue. So current player is blue. Game round 0. Who'd like to shoot? Red. Built-in function has no method rand int. Okay. Random dot. So this is in attack target, isn't it? Okay, so random dot randint. Why can't it find random? So I'm just gonna say, this is random in here. Random is here. Random dot randint 0 to 100. So that should be working. I don't know why it's not. Try it again. Red. Okay, I'll just have to fix this up and I'll just get back to you. main. So I need to go to game, not that game. Random. Okay. So I need to do game. So the problem is that I shouldn't be doing like this. I should be just doing just input random. That's probably why it's not running. If I try doing it again, red. Okay, there we go. So we can see who would you like to shoot red. Player blue missed. Players alive include blue, red, and yellow. Still, that's good. Current player is red. Red attempted to shoot blue, red hit. So now it's just red and yellow left over. And then we're going to say current player is yellow. Yellow attempted to shoot player red. Yellow hit. Players alive include yellow. Great, so that's how you do the entire problem. Sorry about that. I actually had to go back to my notes to figure out where the problem was. But now you know how to do this riddle. You just have to set up a tournament. Then you have to set up the wizards. Then you have to set up the game itself. Then you have to set up the conditions for the game continuing. All the while printing out what's happening generally. And if you encounter any sort of bug in IntelliJ, I think also PyCharm has this. You can click on some location. So for example, I can click on here, clicking to the left, which will indicate where to start looking from. This is the exact same thing as Python Visualizer on Google. And then you can just click debug. And what this will do is that it'll start stepping through it just like Python Visualizer. You can just click step over and it will show you what's happening with each line and it'll print out that there. Like what this variable is. For example, player is equal to this instance at something. And if you want to give this something more meaningful, I think you have to do like a toString, whatever it's called in Python. Can't remember exactly what it's called. And then you can print out something specific rather than player at instance, for example. But yeah, that's how you do all that. You just keep stepping through and you can keep finding out what's happening. I'm just going to hit stop on that. Great. Thanks, guys.